Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that we have here where we're going to take a much closer look at rotations. One of the transformations we talked about in Chapter 1, Section 3 was a rotation around a specific point, a point we'll call point P. We're just going to take a closer look at that here. But to get us started, to sort of help us focus our learning, we have an essential question you should be able to answer by the time we get to the end of the notes. That question is, how do you draw an image of a figure under a rotation? After performing a rotation, the transformation known as a rotation, how do you do that? Well, there's several things that you need to know, several things you need to be able to do, skills that you must have in order to answer that question. Those are going to be our objectives. So the things we're going to work through together as we kind of talk about rotations and take a look at example problems. Students will be able to identify the coordinates of the vertices, right? You got to be able to graph things on a coordinate plane. Students will draw the image of figures using rotations. We'll look at some common angles of rotation, all right? There are 4 common angles of rotation. We'll take a look at those. Students will find the rotation given the image and the pre-image using either a ruler, a protractor, or a coordinate grid. Okay, so those are going to be our objectives. These are the things you'll need to be able to do by the time we get to the end of the notes, and all of those things will help you answer our essential question. How do we perform a rotation on a figure? Here we go, let's jump right into it. First of all, a rotation is simply this. You're going to take some pre-image A. We are going to rotate that image around a point. We'll almost always call it point P, but we could call it whatever we want to. So here's my pre-image. Here's my point P. Now, the way that a rotation works is that every point in the pre-image is rotated the exact same measure, the same angle measure, and maintains its distance, simply meaning this: the distance from P to A, that distance right there, has to be congruent to the distance P to A prime. Right? Which is shown to us in the figure by those little dashes. Remember, those little hash marks mean congruent. These have the exact same magnitude and the same shape. They're both line segments, and they're line segments of the same magnitude. So a rotation preserves size and shape. Everything in the pre-image gets rotated the same angle measure, right? And maintains its same distance from that point P. We'll get a look at several of these as we do some example problems. Some common things here to talk about when it comes to graphing rotations. First of all, 360 degrees, you guys are familiar with this. 360 degrees is all the way around a circle and will bring you back to the original image. So if you're given an image and asked to rotate it 360 degrees, the image and the pre-image are the same, right? They lie on top of each other. 360 degrees goes all the way around. Also, if you are not told a direction of rotation, the convention, you are to assume you go counterclockwise, all right? So if I want you to go in a clockwise direction, I must tell you to do so. If I don't tell you the direction, you go counterclockwise. That is the direction we assume we're going unless you're told otherwise. All right, and I've got here several common angles. My pre-image A. I could rotate it 120 degrees to A prime. Distance from my point of rotation to the pre-image, and the image is maintained. I could go 240 degrees, I could go 300 degrees, right? Just several. The idea here, every single one of those is going counterclockwise, right? So you assume a counterclockwise direction of rotation unless you are told to do something different, unless you're told otherwise. Okay, let's go ahead and jump right into this. As I stated here when we started this set of notes, it's this. There are 4 common angles of rotation, and it's these right here: 90 degrees, 180, 270, 360. These are the 4 most common angles of rotation that you're going to be given. In fact, if you're taking this class with me on a test or a quiz, it'll always be one of these four. Why will it be one of these four? Well, because we've already given you the transformations to make that kind of a rotation. So if you're going 90 degrees, the x and the y values switch places and the y becomes negative. 180 degrees, the x and the y stay in their spot, but you make each of them negative. If you're going 270, switch the x and y value, but this time the x is made negative. And we talked about this. If you're going 360 degrees, that's all the way around. One complete rotation, meaning your original object all the way around 360 degrees back to that exact same spot. It shouldn't surprise you one bit that x and y don't change. You're going all the way around right back to where you started. So x and y maps to x and y. All right, it's the same thing. Here we go. Let's do one, right? I think the best way to learn this stuff is just by doing them. Let's do one together, and then you feel free to work ahead if you need to. I've been given a quadrilateral, A, B, C, and D. I'm asked to rotate it 270 degrees. Let me label my vertices. A, B, C, D. Yeah, okay, let's do that. Then what we're going to do is I'm going to rotate it 270 degrees. Guys, anytime you're doing this on a coordinate plane, your point of rotation is always going to be the origin. That'll be your point of rotation unless I tell you to use something different. It's always going to be the origin. That makes it easy. Again, we're going to be rotating in a counterclockwise direction because I didn't specify differently. So we're going to go 270 degrees counterclockwise and find out where that image shows up. Again, go back up to that table if you need to, but the transformation for a 270 degree rotation up there from that chart is the x and y values switch places and the x becomes negative. So it'll be y, comma, negative x. All right, we're going to do that to each of our points. So here we go. A is at the point 1, 1, 4, which means that it is going to get mapped to A prime. Switch the x and y values, make the x negative. So 4 minus 1. B is at 1, 2, 3, 4, is at 4, 2. Switch the x and y value, make the x negative. B prime is going to be at 2 minus 4. There we go. C. I have C at 1, 2, 3, 1. C prime. Switch places. Make the x negative. So 1 minus 3. And one more, D. D is at 0, 2. D prime then will be at 2, 0. Zero's neither a positive or a negative number. It doesn't matter if you put a minus sign in there or not. 0 is just 0. 0 is just 0. All right, here we go. Let's plot those points. 4 minus 1, 1, 2, 3, 4 minus 1. There's A prime. 2 minus 4, 2, 1, 2, 3, 4. There's B prime, A prime, B prime. 1 minus 3, 1, 1, 2, 3, C prime. 2, 0, 2, 0. Right there is D prime, and that right there is my image rotated 270 degrees. Hopefully you can see around this point P. Right here I have gone, right, rotated it around that point, and the angle of measure right here from D to D prime, right, that distance right there, 270 degrees. From A to A prime, that distance right there, 270 degrees. From B to B prime, right, I know it's getting super crazy here, but that distance, 270 degrees. Right, I apologize for all those lines, but hopefully you can see the idea here. Just draw a line from D to your point of rotation, and then from that point of rotation to D prime. That distance, that angle of rotation, 270 degrees. It's going back to that idea. Every point gets rotated the same angle measure and maintains the exact same distance from the point of rotation to both images, D to D prime, okay? We'll try a few more of these together on the next page of the notes. Head on over and I'll meet you guys there.